Hello everyone, welcome to the session. In this session, we are going to discuss about the one of the most important characterization techniques related to the nanostructures or the nanomaterials, that is the scanning electron microscope. That is short form is SEM. In exam point of view, what we need to focus. So generally, in exam version point of view, we should concentrate on the diagrammatic representation. If any keywords should write, or if any formula, definitely you should mention related to the formula, or if any application, you should focus on real world, that means correlate the concept with the real world application and try to write, so that there is no much difficulty in writing the exam on that particular topic. For example, especially in the present video, we are talking about the scanning electron microscope. When you are preparing the concept related to the scanning electron microscope, then you should focus on some of the basic concept. That is, what is the SEM? Why we are using SEM? What is the principle related to the SEM and working principle? That is principle or the working principle, and components of SEM, image formation, and then different modes of operation, and then sample prep is, if any sample preparation requirement, then we should concentrate on the sample preparation, then advantage and limitations and application. This part we should focus. What is this? First one, what is the meaning of SEM? Principle, components related to SEM, how we can capture the image, is there any different modes of operation, and then advantage and limitations and applications. So this part we should concentrate related to the exam version. Dear friends, my attempt is to prepare the content in easy way to the students. If you feel in any point of time the video is useful to you or it is useful for your preparation, please subscribe the channel to continue the channel for different sections. And coming to the exam version point of view, what is the meaning of SEM? So single word sentence like SEM is the short abbreviation related to this scanning electron microscope. It is similar to the XRD and TEM. It is also one of the characterization tool or the characterization technique to understand the material which are in the nano range. That is, generally optical microscope is the one of the instrument used to see the smaller objects, but there is some limitations related to the nanostructure image point of view. Optical microscope limit up to like a 4 to 500 nanometers range it can able to see, but when it comes to the 1 nanometer, there is no possibility to utilize the optical microscope for nano range. So because of this, so it is modified, the microscope is modified with the electrons as the source. Electrons as the source, we are using the electron microscope to see the 1 till 1 nanometer range. It is imaging technique, that is, it gives only the morphological nature, topographical image related to the sample. It won't give the structural information as we discussed in the XRD. So in case of electron microscope point of view, we have two different versions. One is the scanning electron microscope, another one is the transmission electron microscope. So in both cases, the name itself differentiate the principle related to the imaging technique. One is scans the surface. It scans the surface. Second one is it transmit through the sample. So what are the source scans the surface, and what are the sources transmit through the sample? In both cases, electrons scans the surface, electron scans the surface and the result gives in the form of image. Similarly, electron pass through the sample and the result will give the image, that is transmission electron microscope. Scanned electrons is captured by the detector that gives the information related to the scanning electron microscope. I hope it is clear. The main intention related to the SEM is it captures the surface image by scanning the surface with the high energy electrons. So this is about the SEM simple method to characterize the surface of the nanometeors till 1 nanometers. And SEM not only gives the surface property, only the surface, it also gives the elemental information. What are the elements present within the material? For example, the pure gold and copper added gold. How we can differentiate? There is a possibility by taking the SEM, what are the elements present? Whether it is only having the copper, is there any element is added with the copper? Even it gives the ratio between the copper and gold. So SEM is meant for surface characterization. In addition to the surface characterization, we can also take the elemental information by the SEM. Once the electrons scans the surface, once the electron strike the surface, that is the electron sample interaction takes place, that gives different electrons or different X-rays. In this interaction, secondary electrons and backscattered electrons and X-rays, these three interactions are useful to get the image by using the SEM. Secondary electrons are nothing but the interaction takes place from the top surface of the specimen, like a sample, and the back scattered electrons, deep interactions. Secondary electrons are generated because of inelastic interaction between the electron of the sample and the injected electron or the source electron. And whereas backscattered electrons takes place because of the elastic interaction between the incident electron from the source and the electron of the sample. And characteristic X-rays are the once the high incident beam electrons, whatever the source electron, deep interact with the innermost electron of the specimen, the electron will come out. The vacancy of the electron is filled by the higher energy electrons. While coming from high energy to the lower energy orbits, there are possibility of electronic transition takes place. That electronic transitions release the X-rays. So these three are essential. So in exam point of view, when you are writing SEM related, everyone must remember about the meaning for the secondary electrons, backscattered electrons and X-rays. Secondary electrons are the main source to get the topographical image related to the surface of the sample. And backscattered electrons gives the topographical image with low resolution, and it generally used for the different phases. Like in composite, different mixtures, so the different phase information gives by the backscattered electron, and X-rays are the source to give the information about the elemental composition of the sample and the elemental ratio. So elemental information is given by the X-rays. Topographical image, like a surface image, is given, either cracks is there or not, how much size is there, how the shape it is, that all part is related to the secondary electrons, and the backscattered electrons are gives about the different mixtures of phases. This is about the basic thing involved once the source electrons interact with the sample. So for everything we have detectors, secondary electron detector, and it is attached with the computer CRT, and backscattered electron detector, even the X-rays, that is EDS detector also there, and these three are different attachments related to the SEM. Coming to the components of SEM, I hope you have clear about we need some source and we need the sample. Once the source electrons interact with the sample, secondary electrons will come out and backscattered electrons will come out, or X-rays will come out. If you study the only secondary electrons, will get the image. Backscattered electron will get the different mixtures, like a different phases of the material, and the X-rays will get the elemental composition. Then obviously here our intention is we need to focus the high intensity, high strength electrons. It should interact with the matter. So then obviously first the source of the electron, that is called as electron gun. This is one component. Electron gun is the component, but it should have more energy. Electron beam is coming, it should have more energy. How we can give the energy? It should pass through the accelerated voltage. For this purpose, we are using the second component is anode. Here the source of electrons is nothing but electron gun. Accelerating kinetic voltage is supplied by the anode. This is the second component. Third one, electromagnetic lenses or condenser lenses. So it focuses the electrons into the single direction. It focuses the electrons into the towards the sample. Might be there are possibility of electrons may go in different direction, but this condenser lens all the electrons towards the sample. Next one, fourth one, objective lens. So objective lens focus where it need to focus all the electrons, where it need to focus. For example, I want to take the image of this particular area. Then obviously electron need to focus on this particular area only. I don't bother about the other portion because my concentration or my intention is to study this behavior. So then obviously I need to focus all the electrons in this particular area on the sample. Then obviously the object lens is useful to select where it is. So object lens can be movable in a horizontal way or the vertical way. I hope it's clear. If the object lens is far, low intense beam will come. Then obviously more area it will cover and less resolution is possible. If I want to go into the deeper, then object lens need to be moved towards the sample. The distance between the object lens and the specimen should be low. Then we will get the high resolution image. We will get deeper study behavior. And then these secondary electrons are detected by the electron detector, and it connected to the monitor. The monitor will take the signals from the detectors and it will give in the form of image. So that image is related to the surface. So this is the general theory related to the scanning electron microscope. And the scanning electron microscope image is always in the either black and white pattern type of image. So we know that white image will get if you get more electrons from the sample, will get the white image. If the sample is absorbed, some of the electrons will get the dark image. This is about the SEM point of view. And coming to the sample preparation. Sample preparation means some samples may charge like a charge effectively. So to control the charge, we generally use the gold coating or the platinum coating on the sample before placing it into the specimen, like a specimen chamber of the scanning electron microscope. And the advantage point of it is one of the most important characterization tool to understand the surface properties related to the nanostructures, and it is easy handling, and we can go up to the 1 nanometer scale. Sample preparation is not that much difficulty as compared to the TEM, and most it is having applications point of view, but if you want to study the single particle behavior, it's not possible, or more deeper like interplanar distance, it's not possible, and vacuum requirements is more. Limitations is this SEM is not applicable for the volatile components, or easy oxidizing samples are not possible to take the SEM. And this SEM technique can be utilized by the material science people or the biological people, biochemistry people, or different fields. Wherever they want to see the bacteria, there is a possibility to see by using the SEM. This is about the advantage, applications and limitations related to the scanning electron microscope. So diagram, what diagrams we need to mention? So obviously we need to mention the SEM image, at least one kind of SEM image, and magnification and construction diagram related to the SEM. So obviously at least you should focus the construction diagram and the one output like a SEM image, elemental composition, how we can get the elements ratio, or how we can get the elemental composition. In addition to this, we need to write related to the secondary electrons, scattered electrons, and the X-rays importance related to the SEM. So these points you should cover in exam point of view. Thank you.